Okay, so in this video I'm going to be going over the 6.5 to 6.7 quiz practice. So for number 1, it wants us to expand the logarithm. What we're going to do here is we're going to use our logarithm properties to break this up. Give me a second and I will pull those out and show you them really quickly, just in case you've forgotten. Remember, you are allowed to use notes on your quiz. So our logarithm properties are these three. Our product property is putting addition with multiplication, and our quotient property is putting division with subtraction. Our power property takes an exponent and moves it out front. So on number 1, when it wants me to expand it, I'm just breaking it up into more pieces. I'm going to have log base 8. This is going to appear with every single thing I write. I'm going to have 7x, and then I'm going to have log base 8 y to the 6. I used minus to break up the division. Then what I can do is I can break this up even more because 7 and x are actually being multiplied together. So I'm going to have log base 8, 7 plus log base 8 x, because those break up. Remember, multiplication and addition go together. And I'm going to leave this part alone for now. Log base 8 y to the 6. It has an exponent here. Exponents are going to go ahead and move out in front of the equation. So I have log base 8 of 7 plus log base 8 of x minus 6 log base 8 of y. Then I just need to choose my choice. Not this one because it was plus. Not this one because the last one was minus. Not this one because there's 3 pieces. This one is the right answer. Number 2 wants me to expand the logarithm. So I have log base 2. I'm going to have 7, and then because it's multiplication between the 7 and x, I have a plus. Log base 2, x to the 4th. This one has an exponent, so it's going to move out front. I have log base 2 of 7 plus 4 log base 2 of x. So it's not this answer I can see. This one was addition, so it's not, oops, pretend like I didn't draw that line through the bubble. The 4 only went to the x, so it's not this one. Again, it's my last choice. Number 3 wants me to find an equivalent expression for log base 7 of 120, and it's just labeling things A, B, and C. So it's just replacing those. B plus C is saying log base 7 of 10 plus log base 7 of 12. If I use my properties to condense this, it's going to give me log base 7 of 120 because I take 10 times 12. This already is the one I want, so this one is my answer. Number 4 is similar. This one wants me to write an equivalent expression for this. I am going to look at my choices. So let me tear this off. My choices here are b plus 1 minus a. So I would have log base 7 of 9 plus 1 minus log base 7 of 4. Whenever I have 1, remember this is, ooh, I just threw my pen. This is equivalent to me saying log base 7 of 7. So really I have log base 7 of 9 plus log base 7 of 7 minus log base 7 of 4. I can condense these together by multiplying. 9 times 7 is 63. And then these two condense together by dividing when I have subtraction. So I have 63 over 4, which is exactly what I wanted already. So this one is my answer. Number 5 wants me to condense this expression. So first I want to move my exponents back. I'm going to take this 3 and turn it into an exponent. It's going to be log x cubed. And then the second one also has an exponent. That 2 is going to move. So it's log 5 squared. 5 squared is 25. Then I have the minus, so that's going to turn it into a fraction. I have log x cubed over 25. This is my fourth choice. Number 6 is telling me under certain conditions the wind speed in knots at an altitude h meters above a grassy plain can be modeled by the function. It wants me to, number 1, determine the speed for h of 3 meters. So I am going to plug in 3 for h. So I have 2 ln 100 times 3. If I want, I can go to Desmos. Which gives me 11 points. I'm going to do 3 decimal places. 11.408. These are measured in knots. Okay. My friend says that since it's a log equation, the speed will double when h is 30. So I want to plug in 30. Which gets me 16.013. I assume this question was asking me if my friend was correct. Yeah, it was. So this is like not even close to doubling. So my friend is wrong. And for this question, I would just go ahead and show my work that I got me 16.013, and then say my friend is wrong. Number 7 wants me to solve this equation. It wants my answer as the integer value. So these two can both be written as powers of 8. 64 is the same thing as 8 squared. 1 over 8 is the same thing as 8 to the negative 1. Then I want to use my exponent properties. This one's going to give me 8 to the 2x. This one I want to distribute. It's going to give me 8 to the negative x plus 3. Because they have the same base, I can go ahead and take my exponents and add those together. Set those equal together. I have 2x equals negative x plus 3. I want to get all of my x's on the same side. I have 2x plus x, which gives me 3x equals 3. Divide both sides by 3. I get x equals 1. This one wants me to solve the equation, and then my answer will be an integer value. Because they are both log base 5s, I'm just going to take the inside parts and, oops, I didn't highlight this one off, and set those equal together. This is going to give me negative 2x minus 9 equals x plus 6. I want to get all of my x's on the same side, so I add 2x to both sides. I get negative 9 equals 3x plus 6. Subtract 6 on both sides. I get negative 15 equals 3x. Divide both sides by 3. I get x equals negative 5. Number 9 wants me to solve this equation. This one I only have x's on one side, so I'm going to rewrite it as an exponential equation. It's going to become 2 to the 5th power, and it's going to now equal the part in parentheses. So the negative x plus 2. 2 to the 5th power is 32, but if you didn't know this, you could go to Desmos. Remember, I could type in 2 to the 5th. So I'm going to rewrite this as 32 equals negative x plus 2. I want to subtract 2 on both sides. This gets me 30 equals negative x. Divide both sides by negative 1. X equals negative 30. Number 10 wants me to solve the equation, and it wants me to, again, write my answer as an integer value. On the left side, I have two things going on, but they are both log base 5, so I can use logarithmic properties to combine this. Remember, addition is going to multiply the two parts right there, the 6 and the x together. I'm going to have log base 5, 6x equals log base 5 of 30. Now that I have two of the same log bases equaling each other, I just take their inside parts and set those equal. So I'm going to do 6x equals 30. And I'm going to divide by 6 on both sides. This gets me x equals 5. So my answer here is just 5. This one again is similar. I have two of the same log base on the left side, and then it's equaling a number. So I'm going to use exponent properties to get this back at the end. I first want to condense this, so I'm going to do log base 2, and then I'm going to have 2x times x minus 6 equals 5. So I want to go ahead and simplify that part in there in the parentheses. 2x times x gives me 2x squared. 2x times negative 6 gives me negative 12x, negative 12x. And then it still equals 5. I am going to turn this back into an exponential equation. So it's going to be 2 to the 5th, and then it equals the part in the parentheses, 2x squared minus 12x. 2 to the 5th is 32. We saw this on the other problem. And then I'm going to rewrite the right side. I want to go ahead and get everything equal to 0 since this is a quadratic. I have 0 equals 2x squared minus 12x minus 32. Then everything is even, so I'm going to go ahead and divide it by 2 to make it easier for me to factor. That's going to get me 0 equals x squared minus 6x minus 16. I'm looking for what multiplies to negative 16 and adds up to negative 6. This is going to be negative 8. Oops, I forgot my x. And positive 2. So then I'm going to have those and set those each equaling 0. On the first one, I want to add 8 to both sides. I get x equals 8. On the second, I subtract 2 on both sides. I get x equals negative 2. I want to go ahead and since I got 2 answers, I want to check my answer. I am going to plug in 8. When I plug back in 8, oops, I wanted to write this in red. I get log base 2 of 16 plus log base 2 of 2 equals 5. I would use my exponent properties. So I get log base 2 of 32 equals 5. I rewrite it as 2 to the 5th. This does equal 32. I want to again do the same thing for my negative 2. So I have log base 2 of 2 times negative 2 plus log negative 2 minus 6 equals 5. Let's come off the screen. 2 times negative 2 is negative 4 plus log of negative 8 equals 5. I can't have logarithms with negative numbers here. So this one doesn't work. Only the 8 works. So only the 8 is my answer over here. Number 12 wants me to solve for x. So on this one, I want to get the logarithm alone. I'm going to start off by adding 5 to both sides. This gets me log 6x equals 2. I want to use exponent properties to rewrite this. So it's going to be 6 squared equals x. 6 squared is 36. Okay. Now number 13 tells me an exponential model passes through the points below. It wants me to write the model and then figure out the value of y when x is 5. So I'm going to make my own table of values here. I'm going to have 1 and 3, 2 and 12. But I want to go to Desmos and type this in. Remember to do that, I'm going to press this plus, pick the table, and then I'm going to type my points in. Then I'm going to hide this. I want y underscore 1 over arrow over, shift the squiggly line next to 1, a parentheses b exponent x underscore 1. So then it creates an exponential graph through those points, and if I scroll down, it gives me the values for a and b. So a is 0.75, b is 4. If I go back to my paper, this is going to be y equals 0.75 and then parentheses 4 to the x. That's my first answer. My second answer wants me to determine the value of y for x equals 5. So I want to plug in 5 for x. Which gets me 768.